If Carl Sagan taught us to love the stars, Kip Thorne taught us how they dance. He is not just a physicist. He is the architect who mapped the invisible curves of the universe. The man who proved that space and time are not just stages where the cosmic drama unfolds, but active participants, fabrics that can be warped, stretched, and even torn apart by the sheer power of gravity. Standing here in 2026, his work has become the bedrock of our understanding. From the images of black holes captured by the Event Horizon Telescope to the gravitational whispers detected at LIGO, Thorne's math has moved from the chalkboard to the very lens through which we view reality. He looked into the mouth of the abyss, the black hole, and instead of terror, he found a map. Einstein gave us the theory of general relativity, but for decades, it remained an unfinished symphony. Einstein himself doubted we would ever detect the ripples he predicted through gravitational waves. He thought the universe's heartbeat was too faint for human ears. Kip Thorne spent 40 years of his life building a machine that could hear what Einstein thought was silent. Thorne reimagined gravity. It wasn't a mysterious force pulling objects together. It was geometry. Imagine a trampoline with a bowling ball in the center. The ball doesn't pull a marble. It creates a curve that the marble has no choice but to follow. This simple analogy, expanded to 4 dimensions, is the foundation of Thorne's life work. In the late 1960s, Thorne made a bet that defined his career. He proposed LIGO, the Laser Interferometer Gravitational Wave Observatory. Many of his peers thought he was chasing ghosts. To succeed, he had to build a machine capable of measuring a change in distance smaller than 1,000th the diameter of a proton, over a distance of 4 kilometers. LIGO consists of 2 identical detectors, thousands of miles apart. Inside, the world's purest vacuum tubes hold laser beams that bounce off mirrors polished to atomic perfection. It is a testament to human will, a monument built not to look at the light, but to feel the vibration of space-time itself. Then, on a quiet morning in 2015, the machines felt something, a ripple, a tiny vibration that had traveled for 1.3 billion years. 2 massive black holes, each 30 times the mass of our sun, had collided in a distant galaxy. The energy released in that final millisecond was more than the light of all the stars in the observable universe combined. Kip Thorne didn't see the collision. He heard it. It was a chirp. A brief rise in frequency that confirmed Einstein was right and that Thorne's 40-year hunt was over. For the first time in history, humanity had a new sense. We were no longer just observers of light. We were listeners to the gravitational symphony. When Christopher Nolan began work on Interstellar, he didn't want a science fiction advisor. He wanted a partner. Thorne joined the project with a strict condition. The film must honor the laws of physics. This collaboration birthed Gargantua, the most scientifically accurate visual representation of a black hole ever created. What we see in the movie The Glowing Ring of Light is Thorne's math brought to life. He showed us that a black hole's gravity is so intense it acts as a lens, bending light from the back of the disk and wrapping it around the top and bottom. It wasn't just a special effect. It was a simulation that led to new scientific discoveries. In Thorne's universe, time is not a constant. On Miller's planet, near the massive gravity of Gargantua, 1 hour is equivalent to 7 years on Earth. This isn't just a plot point. It is the brutal reality of general relativity. Gravity slows the very heartbeat of time, stretching a single moment into a lifetime. Kip Thorne showed us that space and time are inextricably linked. The deeper you go into a gravitational well, the more time dilates. He forced us to confront the heartbreaking truth of interstellar travel, that to reach for the stars is to leave everyone you love behind in a different flow of time. But Thorne also gave us hope. His work on Lorentzian wormholes explored the mathematical possibility of shortcuts through space-time by folding the fabric of the universe like a piece of paper. He theorized that we could bridge the impossible distances between galaxies in a heartbeat. To keep such a bridge open, Thorne's equations required something called exotic matter, substances with negative energy density that push space outward, while we haven't found it yet. His work remains the blueprint for how humanity might one day conquer the cosmic speed limit. In 2017, the world finally recognized his monumental contribution. Kip Thorne was awarded the Nobel Prize in Physics, but for him, the prize wasn't the end. It was a new beginning, a confirmation that the dark side of the universe, the part that doesn't emit light, is finally within our reach. What lies at the very center of a black hole? The singularity, a place where our laws of physics break down. Thorne continues to hunt for the answers, believing that the union of gravity and quantum mechanics will finally reveal the ultimate secret of how the universe began and how it will end, beyond the Nobel and the Hollywood fame. Kip Thorne remains a teacher. He believes that science is a legacy to be shared. From his legendary bets with Stephen Hawking to his mentorship of the next generation of physicists, he has ensured that the flame of curiosity burns brighter than ever. If Carl Sagan was the soul of space, Kip Thorne is its spine. One taught us to look at the stars with wonder. The other showed us the gravity that holds that wonder together. They represent the two halves of our cosmic journey, the dream and the blueprint. As we look toward the future, Thorne's legacy reminds us that even the darkest, most mysterious places in the cosmos follow laws we can understand. He turned the terrifying void of a black hole into a window of opportunity. He showed us that the architecture of the stars is something we can finally read. Thank you, Kip, for showing us that time is not just a clock, but a journey through the curves of reality. Keep looking up and keep listening to the ripples. Subscribe to Space Atlas. Let's keep exploring the architecture of the stars together.